Now we will discuss about the analytical method of triangle law of vector addition. So you know that when two vectors A arrow and B arrow are represented in magnitude and direction by the two sides of a triangle, then the third side will give you the resultant vector. So in this case, let's say this OP represents the vector A in magnitude and direction, and PQ represents the vector B in magnitude and direction. Then the resultant vector OQ arrow here will give you the resultant vector R arrow equal A arrow plus B arrow. Okay. Now, I want to know how much is the magnitude of this resultant vector. Okay. So for that, we will discuss here. Magnitude of resultant vector R. Okay. Let us imagine that this vector A, which is acting in this direction, and vector B is acting in this direction. Let's say the angle between the two vectors is theta. So in this figure, this theta stands for the angle between vector A and vector B. Okay. Now, from the point Q, we drop a perpendicular QN, right, to the line OP produced. Okay. Then, in this right angle triangle, PNQ, if you take sine theta, let me write here. If you take sine theta, then we know sine is equals to perpendicular by hypo, which means QN by PQ, or sine theta is equals to QN by PQ. How much is PQ? This PQ, when I say PQ, it means the magnitude of this vector B. So for the magnitude, we write only B. Okay, so QN is equals to B sine theta. Okay. Similarly, in this right angle triangle P and Q, if you take cos theta is equals to base upon hypotenuse. Your base is Pn, hypotenuse is PQ again. So cos theta is equals to Pn upon PQ. Again, PQ stands for the magnitude of the vector B, so I'll write B. Next, only Pn will be equals to B cos theta. Okay. Next, now I will apply Pythagoras theorem in a right angle triangle ONQ. See this right angle triangle? So in right angle triangle ONQ, the hypotenuse here is OQ. So OQ square is equals to ON square plus NQ square, or OQ square is equals to ON. This ON can be written as OP plus PM. OP plus PM. And then outside we have square. NQ. Okay, for NQ, we have seen here it is equals to B sine theta. So I'll write B sine theta and then square. Next, OQ square is equals to, how much is OP? This OP is the magnitude of the vector A, so I'll write A plus PN. PN is equals to B cos theta, whole thing square, plus, okay, if you square this, you'll get B square sine square theta. Okay, or OQ square is equals to, now applying a formula A plus B whole thing square, you'll get A square plus B square plus 2AB. 2AB cos theta plus B square sine square theta. Okay, next OQ square is equals to, now I will combine these two. So first A square plus B square. Here I have B square cos square theta, B square plus sine square theta. Now I take common B square, then you'll get cos square inside bracket. And from that term, you'll get only sine square theta. So the term left here is plus 2AB cos theta. Okay. Next. OQ square is equals to A square plus B square. Now how much is this cos square theta plus sine square theta? I think you still remember from the trigonometric identity in class 9 or in class 10, this cos square plus sine square is equals to 1. So 1 times b square will be just b square plus next is 2ab cos theta, or just OQ is equals to root over a square plus b square plus 2ab cos theta. How much is OQ? Now this OQ represent the magnitude of the resultant vector R. So instead of OQ, I will write R is equals to root over A square plus B square plus 2AB cos theta. So this is the magnitude of the resultant vector R. Okay. Next, in which direction this vector R is acting? So to know the directions of the resultant vector, then we need to consider an angle beta. This angle beta is the angle between the resultant vector and the vector A. If you know this angle, then you know in which direction this R is acting. For example, if beta is 0, then it means resultant is acting along vector A. If beta is 30 degree, let's say this angle is 30, then R is acting in this direction. If beta is 90, then R is acting in this direction. So therefore, this angle beta, it's very important, which tells about the directions of the resultant vector R. Okay. So I have a very little space here, so you can take a screenshot for this so that I can rub. Directions of resultant vector. Okay. If beta is the angle made by the resultant vector R with respect to the vector A, then again in this right angle triangle ONQ, if you take tan beta, we know tan is perpendicular by base. So perpendicular is NQ, base is ON. Or tan beta is equals to NQ. We have seen before this NQ is equals to B sine theta. And instead of ON, I can write OP plus PN. Next, tan beta is equals to B sine theta upon OP. OP is equals to the magnitude of vector A, so I'll write A, plus Pn. Pn is equals to how much? Is equals to B cos theta. Okay. So, if you know this tan beta, that means you will know how much is the angle beta. So, by knowing the angle beta, then you will know the directions of the resultant vector. Okay. So, this is my equation 2. So, please note down here, this equation 1 gives you the magnitude of the resultant vector, And this equation 2, it gives you the directions of the resultant vector. Okay. So from this equation 1, let us discuss about some special cases. Okay, let me write here. Number 1. If theta equals 0 degree, theta is this angle. So when theta is 0, it means the vector B is parallel to vector A. So when theta is 0, how much is the resultant vector? R is equals to root A square plus B square plus 2AB cos, instead of theta, I will write 0 degree. And you know cos 0 is equals to 1. So 1 times 2AB will be 2AB. So next we will have R is equals to A square plus B square plus 2AB, or this is equals to root over A square plus B square plus 2AB is equals to A plus B whole thing square. Now this square with this root cancels, so you'll have only A plus B. Okay, so when two vectors A and B are acting in the same direction, then the resultant vector, it will be acting in which direction? So let us find out the direction. So for the direction, I said we have to use this equation. So from equation 2, when you find out the direction, then you'll get tan beta is equals to B sine theta. Sine theta is 0, so I'll write sine 0 degree upon A plus B cos 0 degree. But we know sine 0 is 0. So 0 into B will be 0. So if numerator is 0, right, then if you divide anything by anything to 0, you will get 0. So if tan beta is 0, it means beta is equals to 0 degree. So beta is equals to 0 degree. It means this R also is acting along the two vectors A and B. Okay. So this is the first case. Right. Second case is if theta is equals to 90 degree. That means if vector A is acting in this direction, vector B is acting like this. So the angle between them is 90 degree. So in that case, the magnitude of the resultant vector becomes R equal A square plus B square plus 2AB. Instead of cos theta, you can write cos 90. But we know cos 90 is 0, so 0 into this will be 0. So this term will disappear. So you'll have only root over A square plus B square. So that is the magnitude. What about the direction? The direction is from equation 2, tan beta is equals to B sine, instead of theta we write 90 degree upon A plus B cos 90 degree. But we know sine 90 is 1, so 1 into B will be equals to B. And cos 90 is 0, 0 into B will be 0, so 0 plus A will be A. So only beta will be equals to, taking tan to that side, you'll get tan inverse B upon A. So this gives you the direction. So in this case, when the two vectors are perpendicular to each other, the directions of the two vectors can be found by knowing the magnitude of the two vectors. If you know how much is the length of this vector A and B, then you can find the directions of the resultant vector R. Okay. Third case is if theta equal 180 degree. That is, if one vector is acting in this direction and the second vector, let's say, is acting in this direction. So that is the meaning of theta equal 180 degree. So in that case, the equation 1 becomes R equal root over A square plus B square plus 2AB cos 180. You know cos 180 is equals to minus 1. So minus 1 into plus 2AB will become minus 2AB. So this comes from the formula A square plus B square minus 2AB, which means A minus B whole thing square. So this square with the root cancel, you'll have only A minus B. Okay, so that will give you the magnitude of the resultant vector. And the directions of the resultant vector can be found from equation 2, that is tan beta equal b sine, in this case 180 degree, upon a plus b cos 180. We know sine 180 is 0, so when the numerator is 0, automatically the answer comes out to be 0. So when tan beta is equals to 0, it means beta is equals to 0 degree. Okay, so beta equals 0 degree here, right? Please note down, when beta equals 0 degree, it doesn't mean that beta is acting along vector A, okay, or vector B. But this resultant vector, it should be acting to the greater vector. Like in this case, see, as you can see in the magnitude, this vector B has got more magnitude than vector A. So the resultant vector should be acting along the directions of the greater vector. But if vector A has got more magnitude than vector B, then the resultant vector will be acting along vector A in this case. Alright, so don't get confused. The resultant vector should be acting always in the directions of the greater vector. That is the meaning of this angle in this case. Alright, so with this we will continue in the next video.